Okay, hey guys. Hope you guys are doing good today. This is going to be our last week of getting new work. The only other thing that you're going to have to do after this week will be any makeup work that you need to do that maybe you didn't finish up to this point, or else anything that you want to redo. I know I've had some people that have asked me about redoing things, and you are allowed to redo work. So if you did not make as high as you wanted to on a quiz or a test or an assignment, then next week will be the time for you to do that. You just email me or message me on whatever assignment you want to do on Google Classroom. Send me a message. I would like to redo this, Miss Dyer. Um, and you will have next week to redo do those assignments. The only other thing that you will have to do new after this week will be you will be having a final uh, in this class, and I will probably assign that to you toward the beginning of the week, um, and then that would be due by Sunday, that last Sunday before May the 11th, so Sunday, May the 10th. Um, again, what I'll probably do is I'll make a video where I will go over example questions questions like what you will be asked to answer on the final. I will make a video where I will do that, and I will post that document on Google Classroom so you can print it off. You can work them with me as I work them on the video, and then and I'll probably post that by next Monday, so a week from today, and then you would have until Sunday, May the 10th, to get that final submitted, as well as do any makeup work that you want to do. And again, I would definitely suggest anything that you want to make up or redo, that you would do that before taking the final, because anything that you make up or redo is definitely going to help you on the final in this class. And I know we've done a lot since January, so that's the reason why I am going to take the time to post a review document on Google Classroom, and take the time to make a video going over that review document with you. And that would be all you would need to do next week, would be to watch that review video and practice before taking the final. Again, unless there is something that you want to redo or make up to bring up your grade. So please let me know if you have any questions about that. This week, as you can see here on Google Classroom, I'm giving you a couple of days to just kind of learn about what redox reactions are, as well as to do a practice quiz, and just maybe 3 or 4 short equations where you're identifying what was oxidized, what was reduced, what the oxidizing agent is, and what the reducing agent is. So a couple of days on that, and then you're going to have a couple of days. I'm making the video for today that's going to explain how to do those things I just said, and then I'll make another video that you will need to watch about balancing redox reactions. Using the half reaction method is what we'll be using. So I'll make a video over that, go over that with you, and then you will have another practice quiz on quizzes, as well as I think 3. I'm going to go over a couple of examples with you, and then 3 equations 3 redox reactions that you'll balance on your own using the half reaction method. And that will be, and then I don't have it posted here on Google Classroom yet. I'll probably get that on here tomorrow. But on Friday, you will have a short quiz. It'll be very short because, again, we're just doing very basic redox reactions because we don't have time to do anything more than that. So on Friday, there will be a very short quiz that you would take to show me that you have some idea how to identify oxidation and reduction, as well as balance redox reactions using the half reaction method. So again, that's going to be this week, and that will be all the new material that we will be doing, besides the review and the final, which you will be doing next week. And again, you'll have all next week to make up anything, redo anything, and then watch that video, that review video, and take that final next week. And then you'll be done with chemistry too. So please let me know if you have any questions about any of the plans that we have for this week or next week. So what we want to do now then is we want to talk about redox reactions. You guys, redox actually stands for oxidation and reduction. And so instead of calling them oxidation reduction reactions, which is the actual name, It is shortened to redox reactions, re for reduction and ox for oxidation. So what is oxidation and reduction? That's the first thing that we need to know. Well, oxidation is defined as an increase in oxidation number. So what this means is the oxidation number or charge goes up. So when we look at these redox reactions, we will be able to identify that there is one of the elements that its charge increased. Its charge, its oxidation number went up from before the reaction to after the reaction. So in front of the arrow, it has one charge, one oxidation number. After the arrow, that same element has a different charge or oxidation number. So that we would say that that element or that species was oxidized. And what causes this to happen? Well, you guys, what's happening here is, remember, a transfer of electrons. Electrons are going to be transferred many times, and this is what causes chemical reactions to happen. So when these electrons are transferred, they're transferred from one element to another. So the element that receives the electrons that are being transferred, it is gaining electrons. The element that is transferring the electrons to another element is being oxidized. So we have one element that loses electrons, another element will gain them. So oxidation and reduction have to happen together. One element loses its electrons, another element gains them. So the element that is losing its electrons is being oxidized. We say that it was oxidized. And again, when it loses electrons, remember electrons are negative, and so if an element loses electrons, its oxidation number, its charge increases. Okay, so when the charge goes up, when the oxidation number increases, then this means that the element has lost electrons, and we call that oxidation. Okay, so again, oxidation and reduction happen together. If we have an element losing electrons and becoming oxidized, we have to have another element being reduced, meaning that it's gaining those electrons. Those electrons don't just disappear. When one element loses electrons, another element gains those electrons. And the element that gains those electrons, we say that it has been reduced. Okay, and to me, reduction makes more sense because the oxidation number decreases. Okay, the charge or oxidation number of the element that gains the electrons is reduced. It goes down. So again, the element that is reduced, its charge went down. Its charge was reduced. And how does that happen? Well, that element gained electrons. Again, remember, electrons are negative. So when an element gains more electrons, its charge becomes more negative. It goes down, okay? So the element that lost electrons, its charge goes up because it lost negatives. It was oxidized. The element that gained those electrons, its charge goes down, and so we say it was reduced. So again, oxidation and reduction happen together. Another way that you can remember this is you can use this mnemonic. There's actually a couple of different mnemonics. One mnemonic is oil rig. Oxidation is loss. That means oxidation is losing electrons. So the element that was oxidized lost electrons. And then reduction is gain. Reduction is losing electrons. Reduction is gaining electrons. So oil, oxidation is losing. Reduction is gaining. Oxidation is losing electrons. Reduction is gaining electrons. So that will help you to remember what's happening with electrons. The other mnemonic that you may have heard of before, it's called the Leo, the lion goes grr. Okay, Leo, L-E-O, grr, G-E-R. Leo, losing how does that go? Leo, loss. No, I don't need to give you that one because I'm going to, loss of electrons is oxidation. Okay, so Leo, loss of electrons is oxidation, Leo. And then grr, Leo the lion goes grr, G-E-R, gaining electrons is reduction. So Leo, grr, loss of electrons is oxidation, gaining of electrons is reduction. Okay, that one I don't like to use as well. It just doesn't come off the tongue as easily. Oil rig, to me, I can remember that one better. Oil rig. Oxidation is loss, reduction is gain. Okay, but you can use either one you want to. Oil rig or the Leo the lion goes grr. Okay, so again, as I said, oxidation is always accompanied by reduction. One element loses electrons, it was oxidized. The other element gains those electrons, it was reduced. These reactions, again, are called redox reactions because it's just short for oxidation reduction reaction. Okay, so what we want to do is we want to be able to look at an equation and determine, okay, what element was oxidized, what element was reduced. And so that's what we're going to do here. We have this equation, Na plus Cl2 yields 2 NaCl. In order to identify the substance being oxidized and the substance being reduced, we must first identify the oxidation numbers of all the elements in the reactants and the products. And you guys, this is going to be the hardest part for you, I'm sure. One thing we have to remember is that all elements, all pure elements, just lone elements, always have an oxidation number of 0, okay? So, again here, sodium is 0, chlorine is 0, because this is sodium the element and chlorine the element. So, sodium the element is 0, chlorine the element is 0. So, if it's the element all by itself, its oxidation number is 0. It has a charge of 0. Then in the compound, you know a lot of these oxidation numbers already. Okay, now there are a few that can vary, but for most of these, you know them. So if you have your periodic table, you can get that out and look at it. Again, remember group 1 elements like sodium, potassium, lithium, those are all +1. Group 2 elements like strontium and strontium and barium and calcium, those are always +2. Group 13 elements, those are +3. Group 14, those metals like tin and lead are +4, and then things like carbon are generally going to be -4, but now that one can vary. Again, group 15, those are going to be -3. That's going to be like your nitrogen and your phosphorus. Group 16, that's going to be like your oxygen and your sulfur. Those are -2. And again, oxygen is usually -2. And then your group 17 elements, these are going to be your halogens like fluorine, chlorine, bromine, iodine. Those are going to be -1. And again, in general, remember the element at the beginning of the formula, when you have a formula for an element, for a compound like this one, the element at the beginning is positive, is always going to be the positive one, and then the element at the end is generally going to be the negative one, okay? And so, you know, if you've got an element in there that can vary as far as what its oxidation number is, then you look at that and look at the second part first and just realize, okay, that one's going to be negative, and then the other one's going to be positive. And just like when we were doing Roman numerals, we can usually use our negative to find our positive charge, okay? So we will be practicing identifying those charges as well here in just a few minutes. But in this case, sodium, the element, is 0. Chlorine, the element, is 0. And then in NaCl, sodium is +1 and chlorine is -1, because we know that sodium is in group 1, it's +1. Chlorine is in group 17, and it's always -1. So again, the Na starts out with an oxidation number of 0, and then it ends up at the end having an oxidation number of +1. So what happened here? Its oxidation number went up. This means it lost electrons. And we know the losing of electrons is oxidation. So we would say the sodium was oxidized because it went from sodium with a charge of 0 to sodium with a charge of +1. So in this case, the element that was oxidized was sodium. Again, oxidized meaning its charge increased, its oxidation number increased because it lost electrons. Okay, the chlorine also starts out with an oxidation number of 0, but at the end, it ends up with an oxidation number of -1. Therefore, we say the chlorine has been reduced. It went from chlorine with a charge of 0 to chlorine with a -1. So what does that mean? That means the chlorine gained an electron and its charge went down. Its oxidation number decreased or was reduced. So the chlorine was reduced. Again, reduction is gaining electrons, rig. So it gained electrons, it gained an electron and went down. So what happened here? Sodium lost an electron. It was oxidized. Where did that electron go? Well, chlorine gained it. And so chlorine was reduced. Okay? Now, we also want to talk about oxidation and reduction, oxidizing and reducing agents. In this example that we just did, the substance bringing about the oxidation of the sodium atoms is the chlorine. Thus, the chlorine is the oxidizing agent. In other words, the oxidizing agent is the agent being reduced. Okay? So, in this case, since chlorine was reduced, chlorine is the oxidizing agent. The element or the species that was reduced is the oxidizing agent. And then likewise, the substance bringing about the reduction of chlorine is the sodium. Thus, the sodium is called a reducing agent. Or in other words, the reducing agent is being oxidized. So since sodium was oxidized, it is the reducing agent. So the element that was oxidized, that species that element is in, is the reducing agent. The element that was reduced, that species is the oxidizing agent. Okay, so again, I remember oil rig, oil or oxidation is loss, losing electrons, the charge goes up. Rig, reduction is gain, gaining electrons, the charge goes down. And then I remember the species that was oxidized is the reducing agent. The species that was reduced is the oxidizing agent. So now what we want to do is we want to look at a couple of examples. We're going to look at this example first. And you guys, this is actually the first problem that you're going to be doing on your practice. So if we go back here and look at Google Classroom, okay, you have the practice quiz, but on this practice right here, assigning oxidation numbers and identifying oxidizing and reducing agents, your first problem on that worksheet is this sample problem that we're fixing to do. Okay, and I've got it right here. This is the copy of that. So the very first one that we're going to do here is the one that I'm fixing to go over with you. And then I'm also going to go over maybe one or two more of these with you, some of the ones that I think might be a little bit more or probably maybe one more that I think might be a little bit difficult for you. And then you're going to get to do the other 4 or 5 on your own. So in order to do this, I'm going to open up my Connect here. And I may not even need to do it on there. Hold on just a minute. Let me see if I can get it to connect on here. On my iPad. I always do this on my iPad. You guys know this. Wait a minute. First, I've got to open this up here. Screen mirroring. There we go. So let's see if I can open up my, that's the wrong one. Let me open up my paper here. And I'm going to move this over for just a second. So I can see this problem and write it down. So this is the very first one that we're going to be doing. So we're going to be doing Cr2O3, Cr2O3 plus Al yields Cr plus Al2O3, Al2O3. Okay. So now, let me see if I can get this to go full screen. All right. And now, first of all, you guys, Al was a solid. It's the element aluminum. So remember, all elements have a charge of 0. So I'm just going to, and what you're going to be doing is you're going to be identifying the oxidation number of each element in this equation, okay? That's the first thing I'm asking you to do, because you can't identify oxidation and reduction. You can't identify oxidizing agent and reducing agent until you have identified all the oxidation numbers. And so, once you understand what oxidation and reduction are and what oxidizing and reducing agent are, it's not really difficult to identify those as long as you have the oxidation numbers. The oxidation numbers are what may present some challenges for you. So you're going to have to practice a lot identifying oxidation numbers. That's going to be the most important thing you do, because you can't apply your definitions of oxidation and reduction and oxidizing agent and reducing agent until you can identify these oxidation numbers correctly. So again, all elements, all by themselves, have a charge of 0. So this is aluminum, the element, so its charge is 0. This is chromium, solid chromium. Again, if you notice, if we go back here and we look at these, this has an S after it. That's solid aluminum, so that's the element aluminum. And S, solid chromium, that's the element chromium. So we know those are lone elements all by themselves. And so they both have a charge of 0. Okay? So now let's identify the charge of the chromium and the aluminum in the compounds. So again, oxygen is usually, not always, but usually going to have a charge of -2. So we're going to go ahead and put -2 here for the oxygen on both sides. Okay, so now look how many oxygens we have. We have 6 of them. Or I'm sorry, we have 3 of them. So how much total negative is that? Well, that's -6. Okay, and you guys, this is a compound. So overall, this compound has a charge of 0. It's neutral. The compound is neutral. So what this means then is our positives and negatives have to add up to be 0. Okay? So we have 3 -2s. That gives us -6. So how much positive do we need? Well, we need +6 to cancel out to give us an overall charge of this compound of 0. So we have 2 chromiums here. So 2 times what equals positive 6? How much positive charge does each chromium have to give us positive 6? Well, it has to be positive 3. Okay? So I hope you can see that. So the chromium here is positive 3. 2 positive 3 chromiums gives us a positive 6 charge. 3 negative 2 oxygens gives us a negative 6 charge. Positive 6 negative 6 gives us that neutral compound, that is Cr2O3. Okay, let's do the very similar thing to our aluminum oxide compound over here. Again, 3 oxygens, each one we know is negative 2, gives us a total charge of negative 6. And I'm having trouble writing that. All right, now, so again, this is a neutral compound. Its overall charge is 0, so that means our positive charge has to be positive 6. So, again, we have 2 aluminums. Aluminum has a charge of, what does aluminum have to have a charge of to give us positive 6 if there are 2 of them? Again, 2 times what equals positive 6? Well, again, it must be positive 3. Okay, so now we know chromium is plus 3, oxygen is negative 2, aluminum is 0, chromium is 0, aluminum is plus 3, oxygen is negative 2. Notice that the oxygen did not change charge. Oxygen was negative 2 at the beginning. It was negative 2 at the end. So, again, like those... when we did those net ionic equations and we marked out the ions that were the same on both sides, we called those spectator ions. It's the same thing here with any element that has the same charge at the beginning and at the end is said to be a spectator ion, meaning that its charge did not change. It wasn't part of the transfer of electrons from one element to the other. So then let's look at this. Our chromium changed charges and our aluminum changed charges, but our oxygen did not. So chromium went from plus 3 to 0. Okay? And then aluminum went from 0, to plus 3. So let's see here. Chromium, what happened to its charge? Its charge went down. Its charge was reduced. That means that chromium was reduced. So if chromium was reduced, then is it the oxidizing agent or the reducing agent? Well, remember, the oxidizing agent was the substance that was reduced. Okay? So this chromium was reduced, so it's the oxidizing agent. Well, this right here is the compound that had chromium in it. So this is the oxidizing agent because it was reduced. Because the chromium was reduced, this is the oxidizing agent. And I know you probably can't see that very well, but anyway, that is the oxidizing agent. Okay? So I'm going to go ahead and mark that out because we're going to need to write something here in just a minute underneath here because I'm out of room at the top. All right, so now let's look at the aluminum. The aluminum started out at 0, went to positive 3. So again, obviously its charge increased. This means that it lost electrons, and so the aluminum was oxidized. So this means then that this aluminum is the reducing agent because it was oxidized. Again, our chromium went from plus 3 to 0. And so it was, right here we see the chromium went from plus 3 to 0 at the end of the reaction. So it was reduced. That means it's the oxidizing agent. This is the oxidizing agent. Again, the oxidizing and reducing agent are going to be here at the beginning of the reaction, okay? Because they are the ones that are present at the beginning. So since the chromium was reduced because it went from plus 3 to 0, then this chromium oxide was the oxidizing agent. And since the aluminum was oxidized because it went from 0 to positive 3, then this aluminum is the reducing agent. So again, the oxidizing and reducing agents are always going to be here at the beginning of the reaction. But we do have to consider those things at the end to determine were they oxidized or reduced. Okay, so let's try one more. At least one more. I don't want to write you right now. Not now. Come on. Okay, anyway. All right, so then let's look at, and I'll have to probably open that up again. Okay. Sorry, it messed up on me. All right, so let me move this back over here and let's look at another example. I want to do another example with you. So what I wanted to do, I wanted to try to look at this this one here because it's a little bit long and I thought it might give you some challenges just because it's so long. So I thought that we would try to look at it. So MnO2 plus 4H plus 2Cl minus, and that's going to give us I'm going to have to erase this and do this again because this is going to be, like, I'm taking up too much room here at the beginning. I'm not going to be able to write the whole thing. Okay, so let me try it one more time. MnO2, I'm going to write it smaller. 4H plus, okay, 2Cl minus, and then we're going to get Mn2 plus, and we're going to get 2H2O, and we're going to get Cl2. Okay, so the first thing I see here is that we're given the charges of many of these things. Okay, this hydrogen, we can see it right there. It's +1. Okay, we can see this chlorine is -1. So it gives us the Mn there. This Mn here after the arrow is +2. Okay, we can see that. All right, so now the chlorine. Well, notice that this chlorine here is G. That's chlorine gas. It's Cl2, a diatomic element. That's chlorine the element. So its charge is 0. All right, so the only things we really need to determine then here are the H2O and the MnO2. So I'm going to go ahead and put this full screen now. Okay, so remember we said the oxygen's charge is usually what? Especially if it's the second part of the, remember, the first part of the compound is going to be your positive part, and the second part of the compound is going to be your negative part. So here the oxygen is the second part of our compound. This is manganese oxide. Obviously, it's supposed to probably have a Roman numeral in there too, but we're not going to worry about that at this point. So anyway, this oxygen we know has to be negative, and we know this oxygen has to be negative because they're the second part of the compound. And again, we said oxygen is usually -2. It's in group 16. It's usually -2. So oxygen is -2. We're going to go ahead and say that. Okay, so again, remember, this is a compound. So overall, it's neutral. This is a compound. So overall, it's neutral. And you guys, it doesn't matter that 2 there in the front. For what we're doing right now, that 2 there does not matter. That 4 there does not matter. Now, when I make another video and you guys for Wednesday, that may matter, but right now it doesn't matter. So we're not going to worry about the 4. We're not going to worry about the 2. All we're going to worry about is the compound. So we know water is a neutral compound, so its overall charge is 0. This manganese oxide is a neutral compound. Its overall charge is 0. We know oxygen is usually -2, so -2. So here there's 2 oxygens, so 2 -2s gives us -4. If I can write that on there, okay, -4. All right, so then notice how many manganese are there here. Since there's no subscript, we know there's 1 manganese. So we have -4. We need positive, sorry, the X is getting in my way. We need a +4 to cancel out the -4. Well, we know there's only 1 manganese, so that manganese has to be +4. The charge of the manganese is +4. Okay, over here we have 1 oxygen. Its charge is -2. Again, there's no subscript there, so we know that's 1 oxygen. Its charge is -2, so the overall negative charge is -2. So that if this water is neutral, then we know that we have to have +2. And there's 2 hydrogens, so how much does each hydrogen have to be to give us +2? Well, it has to be +4. Okay? So now we have the oxidation number of all the species. The manganese is +4. This oxygen is -2. The hydrogen is +1. The chlorine is -1. The manganese is +2. The hydrogen here is +1. The oxygen is -2. The chlorine is 0. All right. So again, we see here that oxygen is just a spectator ion. It doesn't change charges. The hydrogen is just a spectator ion. It isn't changing charges. What's changing charges here? We only have 2 elements that are changing charges. The manganese is changing from +4 to +2. So manganese is +4 on the left. And on the right side of the arrow, it's +2. And then the chlorine. On the left side of the arrow, the chlorine is -1. On the right side of the arrow, the chlorine is 0. Okay? So, we can see here that the manganese, its charge went down from +4 to +2. This means that it gained electrons. Okay? Reduction is gain. it gained electrons. Or we can just see here, oh, its oxidation number went down. Its oxidation number was reduced. So the manganese was reduced. Okay? And if it was reduced, then what does that mean? Whatever we have over here at the beginning that has, whatever we have over here at the beginning that has manganese in it, that was our oxidizing agent because manganese was reduced. That's our oxidizing agent. So this is our oxidizing agent, and I'm not going to write it all out. I'm just going to abbreviate. Okay? Now, let's look at the chlorine. The chlorine went from -1 to 0. Its charge went up. That means it lost electrons. Its charge went up. Oxidation is loss. So this chlorine was oxidized. So again, remember the thing that was oxidized, well, it's the reducing agent. So whatever we had over here that had chlorine in it, that was our reducing agent. So this is our reducing agent. Okay? And you guys, that's how you do oxidation reduction reactions. You have to look at the oxidation numbers of the compounds. Let's go ahead and look at number 5. Looks like it might be difficult too, so we're going to go ahead and look at it as well. So we've got C6H12O6. So C6H12O6. And then we have O2, 6O2, which again, remember, for what we're doing today, that doesn't matter. Then we have 6CO2. And we have 6H2O. 6H2O. All right. And again, we don't have any lone elements here, so we don't have anything that has a charge of 0. All right, so let's look. Well, yes, we do. This oxygen here, if we go back and look, this oxygen here is oxygen gas, O2, the diatomic element. So I didn't even notice that. So that is a lone element, so we know its charge is 0. All right, so then let's look over here. We have, if we assume that oxygen is -2, then that's -12. We assume that this hydrogen is +1, so that gives us +12. So then we'll assume that that carbon, is 0. Okay, and again, this is a compound. Its overall charge is 0. So if we have -12, the hydrogen is +1, that's +12, then we're going to assume that carbon is 0. Then over here, we have -2 for carbon, or I mean for oxygen. Again, carbon is, carbon dioxide is a compound, so its overall charge should be 0. So 2 -2s is -4. 1 carbon, so it must be +4. Okay, and then here, water is going to be neutral. There's 1 oxygen with a charge of -2, so that's total -2, so we have to have a +2. So then that means that the hydrogen is +1. All right, so let's see here. I think what we have to do here, and you guys, this is the reason why I did this one with you. Sometimes, now remember, hydrogen is in group 1, but it can also be in group 17 right beside helium. So sometimes hydrogen can be +1, but sometimes hydrogen can be -1. And in this case, I'm thinking hydrogen is probably -1, okay? So if we have -1 here, -2 for oxygen, that's -12. -1 here for hydrogen, that's another -12. So we have -24. So how do we cancel out that -24? Well, we need a +24, and I'm probably not going to be able to write that for that X. But anyway, +24. So we have 6 carbons, so each one has to be +4. Okay, so here at the beginning, carbon, and this is the reason why I did this one with you, because hydrogen can sometimes have different oxidation numbers. Again, since it was at the very beginning, the carbon is at the very beginning, so it's probably the positive, and then the oxygen and hydrogen there toward the end are going to be the negative parts. Again, your negative parts are going to be at the end, your positive parts are at the beginning, so that's why this carbon has to be +4. And then at the end, carbon is also +4. So it didn't change. You see that? So the carbon was not oxidized or reduced. It was +4 at the beginning, and it was +4 at the end. So it's probably one of those spectator ions. So let's look at the hydrogen. At the beginning, it was -1. At the end, it was +1. So hydrogen at the beginning was -1. Hydrogen at the end was +1. And then what else changed charge? Well, the oxygen. The oxygen at the beginning was 0. At the end, it was -2. Okay, so we can see here that the hydrogen went from -1 to +1. So its oxidation number went up. If your oxidation number went up, that meant you lost electrons. So this thing was oxidized. The hydrogen was oxidized. And then the oxygen was reduced. Its charge went down. Its charge was reduced. So that means it gained electrons. So its charge was reduced. So whatever we have at the beginning that had hydrogen in it, well, that was, if it was oxidized, that was our reducing agent. So then that means that this glucose here, this C6H12O6, it was the oxidizing agent because the hydrogen was oxidized, or the hydrogen was oxidized. That means it's our reducing agent. I'm sorry. So reducing agent because the hydrogen was oxidized. And then the oxygen here at the beginning, since it was reduced because its charge went from 0 to -2, it is our oxidizing agent. Okay? So again, carbon was +4 at the beginning, carbon was +4 at the end. So it was a spectator ion. Hydrogen was -1 at the beginning, but it was +1 at the end. So it was oxidized. Because its oxidation number went up, it was oxidized. That means it's our reducing agent. Okay, this oxygen and this oxygen were both -2. So we might say that's a spectator ion. It's this oxygen that we're looking at. This oxygen was 0 at the beginning, but at the end oxygen is -2. So this oxygen gained electrons. It was reduced. So this oxygen was the oxidizing agent. Okay, and again, that's the reason why I did that one with you as well, because I knew that one was going to be a little bit tricky. So we have done this one here at the top, so you should complete that one. We have also done number 4 and 5, so you should complete those two. So that leaves you number 1, 2, 3, and 6. And those should not be very difficult for you at all. Okay? Please let me know if you have any questions, and I'll be talking to you later. Bye-bye.